Billions of years ago, Mars had a thick atmosphere, flowing water, and a warm climate. Today, it is a frigid, dry desert. The oceans evaporated, and the thick air was stripped away into the vacuum of space. Researchers point to the solar wind as the primary cause of this violent planetary transformation. The solar wind is a steady stream of charged particles flowing outward from the sun. For billions of years, this relentless outward pressure has chipped away at the Martian atmosphere. As the air thinned, the entire planet cooled, and the surface water vanished. We know the solar wind is responsible, but scientists have never been able to observe the real-time physical mechanics of exactly how these charged particles pull an atmosphere apart. With human missions to Mars on the horizon, this gap in our knowledge is a massive liability. We are planning to send astronauts into a harsh environment shaped by violent space weather, and we still do not fully understand the weather itself. To solve this, NASA launched the twin probes of the ESCAPADE mission. ESCAPADE stands for Escape and Plasma Acceleration and Dynamics Explorers. This vector map illustrates the mission's unorthodox route. Instead of flying straight to Mars, the two spacecraft are currently looping around Lagrange Point 2. Lagrange Point 2 is a gravitational pocket in space, located about 1 million miles from Earth. This large 2 million-mile loop carries the probes directly through a region known as Earth's magnetotail. The magnetotail is the portion of Earth's magnetic environment that is stretched out and pushed away from the sun. Principal investigator Rob Lillis notes, "No one has ever measured Earth's tail this far away. When Earth and Mars align in November 2026, the spacecraft will swing back past Earth. They will use the planet's gravity to propel themselves outward, aiming for a September 2027 arrival at Mars." This deep space loiter gives the probes months of extra time to study the solar wind and the magnetic conditions of interplanetary space. They are mapping the exact environment that future human crews will travel through. When the spacecraft reach Mars, they will initially fall into the exact same orbital path, passing over identical regions at slightly different times. Previous missions were severely limited. A single spacecraft can fly high to measure the incoming solar wind, or it can fly low to measure the planet's atmosphere. It cannot measure both at once. This diagram shows ESCAPADE's solution. After about 6 months, the twin spacecraft will split into 2 distinct separated orbits, giving scientists a simultaneous stereo perspective. One probe remains further away from the planet. From this high vantage point, it can accurately detect the incoming wave of charged solar wind particles approaching Mars. Just 2 minutes later, the second probe, orbiting closer to the planet, measures the atmospheric particles leaking into space as a direct reaction to that exact wave of solar wind. The probes must account for Mars's highly unusual hybrid magnetosphere. A magnetosphere is the region around a planet influenced by magnetic forces. Because Mars's original field weakened over time, it now relies on scattered, magnetized rocks in its crust and shifting upper atmosphere forces. This broken shield provides very limited protection. By measuring the cause and the effect simultaneously from 2 distinct vantage points, scientists can finally see exactly how the solar wind slips through those weak points to erode the planet. The data ESCAPADE collects directly impacts the survival of any human explorer stepping onto the Martian surface. Earth protects us with a strong global magnetic field. Mars does not. Energetic particles from the sun reach the surface much more easily there, exposing everything on the ground to intense radiation. NASA requires the stereo data collected by these probes to develop precise space weather protocols. This will give human crews the advance warning they need to shelter during solar events directed at Mars. The probes will also map Mars's ionosphere. The ionosphere is a region of the upper atmosphere packed with highly charged particles. Future outposts will rely entirely on the ionosphere to transmit radio waves and bounce GPS navigation signals around the curvature of the planet. These twin probes are drifting quietly above a broken world, mapping the invisible forces that govern the space around it. Decoding the exact mechanics of how Mars lost its atmosphere is the required first step for humanity to learn how to survive there.